afternoon, everyone. So what does the cloud instability theory says? Cloud instability theory. स्ट्रक्चर बताओ मुझे, किसकी थियरी है? बर्गरॉन की. कहाँ से था? नॉर्वे. Therefore, he will talk about what? Ice crystals. It is based on one assumption that water does not freeze even at very cold temperatures. Super cold liquid. It is based on the second assumption that if it is disturbed, then it will start freezing. Who will disturb it? Disturb it? Any kind of an ice nuclei. So theory, step 1, introduction of an ice. Therefore, step 2, surrounding water freezes. Therefore, step 3, as it becomes heavy, it starts falling down. Therefore, step 4, it will freeze the more and more surrounding regions. And step 5, as it keeps on falling down, it will convert the entire cloud into ice cloud, and thus it will start falling as rain. Fine? This is what is the cloud instability theory or Burgon process. Past year question, Burgon process fails to explain the rainfall in certain regions of the world, or Burgon process is not a complete explanation of the process of condensation. Why? Because it cannot explain the rainfall patterns in the regions of tropics. Kaise nahi? You have to explain that in little bit detail. That is, in the regions of tropics, sometimes the rain occurs from the clouds at a very low height. Nimbostratus clouds inko kehte hain. You have to specifically mention that is the nimbostratus cloud. And this nimbostratus clouds, when they are at a lower height, it means there is no chance of ice crystal in it. If in the tropics the cloud is it at a very great height, and if it is giving the rainfall, then you can understand ki haan, ho sakta hai, there can be a chance of an snow ice crystals, but it is not having any ice crystals in it, and therefore still it is giving the rainfall. That means this theory fails to explain. Second, it fails to explain jahan pe the convective rainfall, jahan pe the conditions are very, very hot. But most importantly is the above factor. Easy? And therefore, we have the next theory, that is the collision coalescence theory. The collision coalescence theory. So you must have seen in 1 week मेरा बहुत ड्रास्टिक इम्प्रूवमेंट हुआ है. एटलीस्ट आई कैन फील दैट. जो मैं पहले बहुत टेढ़ा होकर चलता था, एटलीस्ट आई एम वॉकिंग स्ट्रेट. बट उसमें एक प्रॉब्लम ये होता है, द फिजियोथेरेपिस्ट विच इज़ वेयर आई गो नाउ डेज इज मेकिंग मी डू एक्सरसाइजेस, एंड उसमें कभी कभी पेन बढ़ जाता है. ही सेज मैक्सिमम 5 to 6 more days, उसके बाद आई विल बी नॉर्मल. सो इसीलिए येस्टरडे आई हैव टू गिव यू ऑफ. Collision coalescence theory. But thankfully I went there, otherwise जिससे मैं पहले कर रहा था वो मेरी केस इतनी बिगाड़ देता कि I would have to undergo operation only बाद. Yes. Deepavali holidays. 26, 27, 20. 27th is the Deepavali? 27th is Diwali? So 4 days, 26, 27, 28, 29th. होते हैं. तो स्टूडेंट्स कहाँ जाते हैं दिवाली में? मैं कहाँ जाता था दिवाली में? दिवाली में स्टूडेंट्स नहीं जाते. दिवाली टीचर्स के लिए होती है, जो जाती है और 4-5 दिन आ जाते हैं. स्टूडेंट्स तो पढ़ाई करते हैं दिवाली में. हाँ हाँ. ठीक है, हम दिवाली की डिसाइड कर लेंगे आपको किसको कहाँ जाना है और कितने दिन चाहिए. रिजर्वेशन आप करा लो. You take from 26 to 30. 26 to 30 is enough. Saturday is 26th. Saturday is 26th. मेरे को 2 दिन देना, मैं एग्जैक्टली बता दूंगा ये क्लास कितने दिन बंद होने वाला है. Those who are in GS आपको 3 दिन मिलने वाली है. So collision coalescence theory came, I'll tell you exactly what is the holiday, whether 25th to 30 or 26th to 30, fine? Because 25th is Dhanteras. So you can start from here on 25th, those who are going outside. You go one day before Diwali and 29th को निकलो वहाँ से या 30th को निकलो, come to class on 31st, fine? दिवाली में इस साल पोल्यूशन नहीं होगा इतना. There has been enough good rainfall, so there won't be that much pollution. पिछले साल pollution था because there was no rainfall. So collision coalescence theory talks about the rainfall in the warmer climates, जहाँ पे rainfall will start very near to the ground. Now it talks about कि instead of supercooled liquid there is hygroscopic nuclei. अब see what is the difference in the word. वहाँ पे there was a condensation nuclei, he talks about hygroscopic nuclei. Condensation nuclei is the nuclei जहाँ पे ice particles will condense and become cold and through the process of sublimation. Hygroscopic nuclei are the particulate matters जिसके ऊपर water droplet will condense. There will be numerous such water droplets which will condense to form the cloud droplets. Over the period of time, these cloud droplets will collide with each other, and as they collide with each other, they will grow larger in size. The time they grow larger in size, they become so heavy that they start falling down as rain. This is what is the collision coalescence theory. And is it right? Is it wrong? Yes, it is extremely right theory which talks about the growing of the water droplets, because you should know कि हर जगह snowfall से rainfall does not start. Means not every rainfall starts as snow and while coming down it will melt to form a rain. Sometimes it starts directly as water particles. It does not just freeze. Fine. So collision coalescence theory. The collision coalescence theory came as an answer to the Bergeron process, which could not explain satisfactorily the mechanism of rainfall or precipitation in the tropics. Full stop. In the tropics. It also could not explain the mechanism in the oceanic regions, where rainfall occurs just from the height of 2 kilometers, where rainfall occurs from cumulonimbus clouds, from cumulonimbus clouds from the height of 2 kilometers, from the height of 2 kilometers. The process of coalescence, the process of coalescence was discovered by Bowen. बोवेन कहाँ से था? ऑस्ट्रेलिया से. So obviously उसने देखा कि मेरे यहाँ पे there is no snowfall and therefore he gave the process of collision coalescence theory. Was discovered by Bowen, who removed the belief that only drizzle can occur from the clouds located below, 2,400 meters. 2,400 meters. Now we don't have to write this background. I'll tell you the background. Bowen discovered that rainfall, very heavy rainfall, can occur on the clouds which are below 2 kilometers, that is 2,400 meters. Secondly, he calculated the temperature with the help of balloon at the top of those clouds, and the temperature at the top of those clouds all over the world, he did the record, and kahin pe bhi usko temperature less than 0.7 degrees Celsius mila nahi. This is the lowest limit he found, means it is not less than 0 degrees Celsius, which shows that snow will not be formed, and still there is a heavy rainfall. Fine, and therefore he came up with the process of collision and coalescence. Iske bhi critics hai. There are critics who say that even after colliding, why do the rain droplets join together? Why? Yes, not above that. 2,400 meters ki average height. So obviously uske above there will be very cold. So there are some critics who say that after colliding there are some rain droplets which may be splitting. Yes, there are some rain droplets which may be splitting. Splitting generally occurs when there is a very strong convectional currents, and therefore charges get separated, positive charge and negative charge get separated, and there is lightning and thunder. But in the most cases, the rain droplets after colliding will join together and grow larger in size, and that is what is known as coalescence. So क्या हो रहा है? सबसे पहले there is a collision, and collision के बाद there is splitting, no splitting. What is occurring is the growth, larger growth, and therefore we call this theory as collision coalescence model of cloud formation. Who gave this theory? This theory was given by numerous meteorologists. Process was discovered by Bowen. He did not give the theory. This theory was given by numerous meteorologists. Next. Many clouds have temperature in the uppermost part. Many clouds have temperature in the uppermost part. Greater than 0.7 degrees Celsius. Greater than 0.7 degrees Celsius. Such clouds are known as warm clouds. Such clouds are known as warm clouds. And the occurrence of the precipitation is not due to snow. Next point, as the water vapor rises upwards, condense around hygroscopic material such as sea salt, dust particles, pollen grains, such as sea salt, dust particles, pollen grains. Sea salt जो evaporation से आता है, pollen grains. Next, due to winds and air currents, these water droplets grow larger in size. These water droplets grow larger in size. Full stop. Sometimes electrical attraction between the droplets having opposite charge also help in electrical attraction between the droplets having opposite charge also help in coalescence. In the bracket लिखना also help in coalescence. Opposite charges will attract. Once they get attracted, they will join together and therefore they will grow larger in size. Understanding? Also help in coalescence. This concept was given by Charles Murray, electrical charges wala. In the bracket, if you want, you can write Charles Murray. What do you mean by microns? Size -6. What is micrometer? Is it same as microns? (10⁻⁻6) only, same as microns. याद रख. As the size of the particles start growing, they start falling down as rain or snow. They start falling down as rain. If the particle size is around 500 micron in diameter, if the particle size is around 500 microns in diameter, millimeter se chota micrometer, that is microns only, microns in diameter, the precipitation will be in the form of drizzle. The precipitation will be in the form of drizzle. While if it is greater than 500 microns, it will be rainfall. It will be rainfall. Next point. Thus the collision coalescence theory has been able to explain has been able to explain satisfactorily the rainfall in the tropical regions, which occurs from very low height, It is also able to explain why the presence of hygroscopic nuclei is essential for the precipitation. And you can write यहाँ पे rainfall क्योंकि इस region में कभी snowfall नहीं होने वाला. It is only in the tropics. Understanding? There are numerous hygroscopic nucleus. They will grow larger in size by colliding. Then they will form clouds. Cloud becomes so big कि हवा उसका वजन नहीं उठा सकती. It starts falling as rain. This is what is the collision coalescence theory. Can I continue? देखो starting का ही word है. Unlike the Vargon process where the precipitation forms under the supercooled condition, the collision coalescence process typically occurs in the So you can see here in this diagram, इतना diagram हम बनाएंगे नहीं. Updraft, converging air, low pressure, air is forced to go up. ऊपर जाके they will form a larger cloud droplets. Small cloud droplets will collide to form a larger cloud droplet. This larger cloud droplet now starts falling downwards. It is again colliding with numerous cloud droplets, resulting into instability and ultimately to the rainfall. This is what is the collision coalescence process. इसके अंदर जाने की ज़रूरत नहीं, because this is physics. Collision efficiency कितनी होनी चाहिए, कितना size of the particles होना चाहिए, etc. So इसमें जाने की ज़रूरत नहीं. But understood this process, this is what is the collision coalescence process. कुछ नहीं, diagrams for both will be same. That is why I have not taken the another diagram. सिर्फ उसमें ये है कि had this been Bergeron process, this would have been snow. Because this is a collision process, यहाँ पे लिखा है this is a raindrop. Getting it? What? Not necessarily, not necessarily. Updraft के कारण पहले cloud particles, water droplets ऊपर जाके cool हो रहे हैं. उसके बाद collision कैसे भी होगा. It can be this way also, it can be this way also. Updraft is, why will the water vapor cool? Adiabatic change. So adiabatic change means it has to go up. ऊपर कौन लेके जाएगा? Rising air current. That is why updraft is shown. वो हेल में पड़ा है, फॉर्मेशन ऑफ हेल में पड़ा है, नॉट इन द फॉर्मेशन ऑफ क्लाउड्स. फिर गलत पड़ा था. वर्टिकल अपड्राफ्ट के ऊपर कारण ऊपर जाएंगे वो फ्रीज हो जाएंगे, राइट. डाउन ड्राफ्ट के कारण वो नीचे आएंगे वो मेल्ट हो जाएंगे. फिर से अपड्राफ्ट के कारण ऊपर जाएंगे फ्रीज हो जाएंगे. ऐसे अल्टरनेट फ्रीजिंग एंड मेल्टिंग विल रिजल्ट इनटू फॉर्मेशन ऑफ a very strong particle which is known as hail. Hail में condition is necessary that there has to be updraft and downdraft. It is not necessary in the other cloud formation. In fact, GS में ही पढ़ोगे that convectional currents, that is strong vertical wind shear, इसको हम कहेंगे जब wind ऊपर नीचे जाएगी, we call it as a shear. So vertical wind shear is not a condition for tropical cyclone. Tropical cyclone में कभी भी shear नहीं होना चाहिए. So shear नहीं है, that means are there clouds in the tropical cyclone? Yes, there are so many clouds in the. Then कैसे बने हैं? ये condition तो नहीं है for a tropical cyclone. So collision can be anything, but obviously there has to be updraft of an air because the air has to rise upwards and then cool. And then it can be attraction, it can be falling down, it can be किसी भी type में collision हो सकता है, not necessarily updraft and downdraft. इसलिए tropical cyclone is the only phenomena in which there is a cumulonimbus cloud, still never a hailstorm. Hailstorm never occurs in the tropical cyclone. Vertical shear नहीं होता. वर्टिकल shear मतलब ऊपर जा रहा है नीचे आ रहा है. ट्रॉपिकल साइक्लोन में सिर्फ ऊपर जाता है और फेंका जाता है. दैट इज द वर्टिकल shear. दिस इज द, इसलिए ट्रॉपिकल साइक्लोन में ही हम पढ़ते हैं देयर हैज टू बी हाई प्रेशर अबव, देयर इज नो shear. Shear means air is going up down up down. This is what is the shear. Shear will always result into formation of hail. Clear with the theories of precipitation? So types of precipitation, obviously we are not going to study it for GS. Rain, drizzle, whenever there is a less than 0.5 millimeter or 500 microns. Then there is a snow, then there is rime, then there is hail. There is a different theory in the formation of hailstorms. and thunderstorms कैसे बनते हैं. There are 3 stages of the, I am not going to do it now. So other than that, there are the types of precipitation, and we are coming directly to this, that is what are the types of precipitation. One negative you take down. वैसे there is no negative in the books, but one negative you take down. The collision coalescence process. The collision coalescence process fails to explain why sometimes in spite of presence of humidity and hygroscopic nuclei, precipitation or rainfall does not occur. Second, in the recent years, as the pollution is increasing, this theory cannot properly explain the failure of cloud formation. And उसी point में critics also sometimes argue that collision may result into splitting of the rain droplets. Splitting of the rain droplets. Fine. See, ये critics कौन है? When does the raindrop split? If collision is not the only process responsible. Understand? There is a rain droplet, there is a rain droplet. सिर्फ collide करके वो बड़े नहीं होंगे. One has to be positively charged, the other has to be negatively charged. Then only they will become a big rain droplets. If both of them are positively charged, then it will split. Getting it? So this ये है critics का कहना. And the types of precipitation very simple. Convectional rainfall, orographic rainfall and the cyclonic rainfall. What is the convectional rainfall? दो conditions मुझे बताओ जो necessary है for convectional rainfall from your understanding of the syllabus. What? क्यों क्लियर स्काई? रेन ही नहीं होगी अगर स्काई क्लियर है तो। टेम्परेचर होना चाहिए, मतलब हाई टेम्परेचर। हाई टेम्परेचर से क्या होगा? देयर विल बी वर्टिकल राइज ऑफ द एयर, एज अ रिजल्ट ऑफ दिस देयर विल बी कूलिंग। ऑप्शनल है तो कौन सा वर्ड लिखोगे? एडियाबैटिक कूलिंग, रिजल्टिंग इनटू फॉर्मेशन ऑफ क्लाउड्स, instability and thus rainfall. कहाँ पे होता है? And second condition is sufficient amount of moisture should be there, because if the sufficient amount of moisture is not there, then instead of convectional rainfall we may have the following processes. See, if the moisture is not there, तो क्या होगा? This is how the, instead of convection, only the sand or the dust will rise upwards, and this is what is the dust storm, or this is what is the dust storm. ये कहाँ पे होता है? This happens in the Arabian regions. This happens in the desert regions. कि instead of the sand, and you see dust storms are very powerful. This is a city. This is entirely a city, and the entire dust is coming upwards. Why? The process of convection is going on, but there is no enough moisture, and therefore only the dust rises upwards. Getting it? नहीं, उसमें भी डस्ट होता है, बट आंधी में हमेशा रेनफॉल भी होता है. आंधी इज थंडरस्टॉर्म एंड डस्टस्टॉर्म एक अलग है. डस्टस्टॉर्म के लिए हिंदी में प्रॉपरली वर्ड नहीं है. I don't know the Hindi word for the dust storm. There is a difference between thunderstorm and the dust storm. Andhi is thunderstorm. So open 2018 का paper. And come to paper 2. Question number 1B. 2018 mains paper, paper 2. Can you see the question? Explain the unusual intensity of the dust storms and the thunderstorms across India in the pre-monsoon period of the year 2018. पिछले साल there was huge amount of intensity of dust storms, especially in North India. धूल, dust storms were great in North India. Since I remember कि this is what is the thunderstorm. This is Andhi. Understanding? This is what is the Andhi, thunderstorm. There is lightning, there is thunder, there is, this is what is Andhi, thunderstorm, convectional rainfall, and this is what is the dust storm. There is technical difference. Though Hindi में नहीं होगा technical difference, geographically there is a technical difference. So generally Delhi में there are the thunderstorms. But पिछले साल there were severe dust storms in Delhi, which indicates that climate is becoming more and more drier, which indicates that global warming is a reality. Because of this, the cloud droplets or the hygroscopic nuclei, before colliding and coalescing, they get evaporated due to high temperature. And इसीलिए the intensity of the dust storms have increased. Understanding? These are hygroscopic nuclei. अगर sun का rays ज़्यादा है या heat ज़्यादा है, so before colliding itself only, if they get evaporated, so कहाँ पे moisture बचा रहेगा? And if there is no moisture, this will result into dust storms. Mechanism is same. दोनों का mechanism is same. The only intensity is अगर बारिश है या बारिश नहीं है, moisture है, moisture नहीं है. Understanding? 2-3 दिन, 2 या 3 दिन, 1 वीक तक नहीं होता। Thunderstorm, rain likely in Delhi, lightning thunder in Delhi NCR region, fresh thunderstorm warning in Delhi NCR region, दोनों टोटल अलग है। आंधी इज थंडरस्टॉर्म। एक वीक तक आता है ये प्रोसेस। यू आर फ्रॉम पंजाब, दैट इज वाई। ड्राई रीजन है वो। इट इज टचिंग द राजस्थान। राजस्थान में देयर विल बी डस्ट स्टॉर्म्स एंड देयरफॉर पंजाब में। दिल्ली में 2 days। Last year, this class was supposed to open on 9th of June, but it was cancelled because of cancellation of flights due to Delhi dust storm. 2nd of June. Then we opened this class on 9th of June. This was supposed to open on 2nd of June. We all were in the Pune center. I was home, ma'am was at her in-laws place, holidays tha, and we thought कि चलो 2nd of June को we should be coming to Delhi. But अचानक there was a dust storm. Convection, the process of convection का day and night से लेना देना है. It has nothing to do with the dust storm and thunderstorm होगा कि नहीं, that depends totally on the moisture. Now I will tell what is convectional rainfall or what is the process of convection. This is a ground surface. When the sun is vertically overhead, yeah, during the summer season, sun will rise, 12 बजे के आसपास sun will get vertically overhead and sun will heat up the ground most. The ground will get heated and around 3 to 4 o'clock, the ground will start giving out excess heat to the surrounding atmosphere, and therefore low pressure will develop because the source of heating of the atmosphere is not the sun, it is the ground. Sun will heat the ground maximum from 12 to 3, धूप जब सबसे तेज होती है, but गर्मी, that is the air will start getting heated at around 4 o'clock, and therefore this air will start rising upwards from this region. As this air will start rising upwards, wind from the surrounding region will be pulled in this low pressure, because when this becomes a low pressure, as the air rises, surrounding regions obviously become high pressure, and therefore the winds will start blowing. Depending upon how strong this low pressure center is, the wind ka speed will increase, and when the winds will come here with great speed, they will bring in the desert regions, they will blow the sands, giving rise to dust storms. In the semi-arid regions, they will blow the sands, giving rise to dust storms. In this region also, they will start blowing the sands, but if there is enough humidity, when this wind comes here, air comes here, it will also start rising upwards. And when it starts vertically rising upwards, the cloud which is formed is cumulonimbus cloud. Cumulonimbus cloud will be formed. हमने परसों के लेक्चर में किया था, जब वो ऐसे जाएगी तो निम्बो स्ट्रेटस क्लाउड्स, जब वो वर्टिकली अपवर्ड्स जाएगी तो cumulonimbus clouds or cumulus clouds will be formed, and then it will give very, very heavy rainfall, and when it gives the heavy rainfall, it is known as dust storms. Sorry, thunderstorms. When it does not give the rainfall, it is known as dust storms. Fine. Secondly, कहाँ पे rainfall ज़्यादा हुआ है in this last 2 days? In which part of India? Pune. Pune has seen one of the worst rainfall, कि गाड़ियाँ बह गई. In last 100 years, Pune has seen, in the city, you can see, photos देखे, गाड़ियाँ बह रही है, ये बह रहा है, क्यों? क्यों पुणे में, क्यों नहीं मुंबई में? Which is this season? Retreating monsoon. So the winds are coming from north to south. So orographic effect is now seen on the other side. When we say Western Ghats, southwest monsoon is forced to rise upwards. Windward side, leeward side. Retreating monsoon, winds is going like this. So now they are forced to rise upwards due to Western Ghats from this side, and therefore this side receives very, very heavy rainfall. Understanding? Understand this all with the help orographic rainfall. जब साउथ वेस्ट मानसून आता है तो orographic rainfall occurs here. जब retreating monsoon होता है तो orographic rainfall will occur on the other side. This is all an orographic rainfall. And कहाँ से moisture हुआ? क्यों इसी साल? This year there has been more rainfall, very heavy rainfall. So already the atmosphere is so moist. It is so moist in Delhi, if already the temperatures have started falling very suddenly now. Day mein temperatures are very hot, maybe it is high, but night mein temperatures are lesser. ये शुरू हो गया retreating monsoon and the October heat. अभी तो कुल्ला फिलहाल कुछ नहीं लगेगा. Let this moisture get evaporated. Let the sun का clouds get totally evaporated, and then the day में the sun rays will be very strong. Insolation will be very high, but night में temperature will be very less. And that is what is known as October heat in the coming month of October. And उसके बाद winter शुरू हो जाएगा. Now, because of the just previous months of rainfall, there is so much moisture कि if the air is going upwards, it is already humid. उसका humidity capacity is suddenly decreasing because of being forced upwards by the Western Ghats. उसका humidity capacity decreases, relative humidity increases, and it is giving the rainfall. उस दिन मैंने कहा था आपको कि हमेशा बारिश शाम को होगी, अपने क्लास से बाहर निकले और बारिश शुरू थी. Fine? Understand this with the help of relative humidity वाला concepts. When is the relative humidity least? In the jump temperature is less. Yes. Northeast monsoon will come now in the winter season. जब northeast monsoon आएगा तब उसमें moisture नहीं बचा है. This is retreating monsoon. वो अलग concept है. Northeast monsoon will properly develop when the winters will come. और आते वक्त moisture कहाँ से मिला उसको? Heavy rainfall all across India. उसके कारण moisture मिला है. अगर normal बारिश होती तो कभी ये phenomena नहीं होता क्योंकि moisture ही नहीं मिलता. But this year is an exception. There has been very heavy rainfall all across India. इसीलिए that is moisture. Otherwise कुछ नहीं होता. And his question on retreating monsoon is, there is a snowfall in the Himalayas. Himalayas will develop, all this area will develop high pressure belt. Fine. Winds will start December में, November में. तब तक moisture पूरा खत्म है. So these are dry winds, except some winds which will pick up moisture from the Bay of Bengal and they will give rainfall to Tamil Nadu. Moisture कहाँ से होता है? GS में क्या बोला मैंने? Moisture is given only by the sea. Rivers are so small कि वो affect ही नहीं करते global hydrological cycle को. वहाँ पे moisture नहीं ज़्यादा होता है, वहाँ पे relative humidity ज़्यादा होता है. Humidity and relative humidity में फ़र्क है. मतलब मैंने इतना समझाया आपको ऐप के एग्जाम्पल के साथ. There is a lot of difference between relative humidity and humidity. Relative humidity is our calculation. In real life there is no relative humidity. Nature करेगा calculation. Absolute humidity upon humidity capacity into 100. ये हमने बनाया है. Reality में क्या है? Humidity capacity and absolute humidity. So इसीलिए convectional rainfall requires two things, that is heat and humidity, and because of this the convectional rainfall occurs only in the afternoon, occurs only in the summer season, and occurs in the continental interiors. Continental interiors never will occur in the regions which are having moderate or maritime climate. Kerala will never have convectional rainfall. Fine. Coastal regions will never have convectional rainfall, but interiors have the convectional rainfall. North India has the convectional rainfall. बहुत ज़्यादा लो प्रेशर कंडीशंस डेवलप होना चाहिए. ओशंस में जब कन्वेक्शन प्रोसेस होता है तो बन जाता है ट्रॉपिकल साइक्लोन. साइक्लोन होगा वहाँ पे, कन्वेक्शनल रेनफॉल नहीं, प्रोसेस ही अलग हो जाएगा. वो प्रोसेस टोटल डिफरेंट है. सो कन्वेक्शनल रेनफॉल कहाँ होता है? कन्वेक्शनल रेनफॉल ऑकर्स wherever the sun rays are vertical. Now where are the sun rays vertical? Sun rays are vertical in the summer season in the subtropics and tropics. Sun rays are vertical throughout the year in the equatorial regions. Fine. And इसीलिए equatorial regions receive rainfall throughout the year from Jan to December. हर दिन rainfall होता है in the equatorial regions. And इसीलिए हमने लिखा दो equatorial regions have very high temperature, relative humidity ज़्यादा है because rainfall होते रहता है. Salinity less है क्योंकि rainfall होता है. Temperature of the oceans is less because rainfall occurs. Fine. Tropical evergreen forest is present in the equatorial regions. While बाकी के जगह in the summers convectional rainfall will occur. Now what are the sources? ये GS के लिए भी अच्छी तरह से करना convectional rainfall. What are the sources for the moisture of the convectional rainfall or heating? It can be anything. कहाँ convectional rainfall is very important. In the desert region, the rainfall is only by the process of convection. How by the process of convection? Because deserts में ज़मीन बहुत ज़्यादा गर्म होती है, it becomes very very hot, and whatever थोड़ा बहुत moisture है, if it is taken up to a greater height, the relative humidity becomes more than 100%, then it will start giving the rainfall. So convectional rainfall occurs in the desert region. Can I say convectional rainfall will never occur outside the temperate regions or outside the subtropical belt, या होगा वहाँ पे भी? Will the convectional rainfall occur in Russia? ये जो पार्ट है साइबेरिया का, यहाँ पे समर टेम्परेचर इज अराउंड 35 to 40 डिग्री सेल्सियस एंड विंटर टेम्परेचर इज समवेयर अराउंड -40 to -50 डिग्री सेल्सियस. मतलब एवरेज एनुअल रेंज ऑफ टेम्परेचर इज मोर देन 100 डिग्री सेल्सियस. एंड यहाँ पे समर्स में देयर इज अ कन्वेक्शनल रेनफॉल. सो कन्वेक्शनल रेनफॉल कैन ऑकर एनीवेयर. अंडरस्टैंडिंग? कन्वेक्शनल रेनफॉल हैज फ्रंट्स भी होगा, वो अलग है. साइक्लोनिक रेनफॉल है. देयर आर 3 kinds of rainfall: convectional, orographic, frontal. This is the frontal rainfall. Second thing about the convectional rainfall is it good or is it bad? Convectional rainfall, is it good or is it bad? GS. Why? अगर कन्वेक्शनल रेनफॉल ही नहीं है तो ट्रॉपिकल एवरग्रीन फॉरेस्ट ही नहीं है तो फिर अमेज़न ही नहीं है, झंझट ही नहीं है जलने मिलने का. So now tell me, is it good or is it bad? It depends upon where you are. If you are in the Amazon rainforest, convectional rainfall is always good. But if you are in Delhi, convectional rainfall is bad because it will result into soil erosion, sudden floods, flash floods, cloud burst. Outside जहाँ पे बारिश नहीं होती, convectional rainfall occurs so suddenly, ये आप उसको कहते हैं बादल फटना, cloud burst. And as a result of this, it will cause soil erosion and destruction. धीरे धीरे समझाता हूँ. पहले main points लिख लो. Convectional rainfall and the world distribution of rainfall. Orographic. कन्वेक्शनल रेनफॉल कभी भी फायदेमंद नहीं होता बिकॉज इतना हैवी रेन होता है कि कल कितना रेन हुआ पूना में परसों. तब तो कभी भी रेनफॉल फायदेमंद नहीं होता. इफ द रीजन इज ड्राई, डेजर्ट रीजन, नहीं, ऐसा नहीं है, ऐसा नहीं है. Whenever, if this is a mountain, whenever the wind will go upwards, it will give very very heavy rainfall, and whenever the wind comes downwards, the amount of rainfall will go on decreasing. जो पार्ट ऊपर है वहाँ पे थोड़ा बहुत रेनफॉल हमेशा होगा, जो फुट हिल्स पे है द रेनफॉल नहीं होगा, बिकॉज रिलेटिव ह्यूमिडिटी गोज ऑन इंक्रीजिंग. नीचे आते आते द टेम्परेचर इंक्रीजेस. रेनफॉल, कन्वेक्शनल रेनफॉल के लिए ज़मीन फ्लैट होनी चाहिए, देन ओनली देयर विल बी अ यूनिफॉर्म लो प्रेशर. यहाँ पे नहीं हो सकता. माउंटेन्स में कभी नहीं होगा कन्वेक्शनल रेनफॉल, बिकॉज जितना ऊपर है माउंटेन उतना हिल स्टेशन. टेम्परेचर हैज टू बी वेरी हाई फॉर द कन्वेक्शनल रेनफॉल. यस. Humidity is water vapor. Moisture can be water droplets plus water vapor. Cloud burst, orography. That year was La Nina year. And that was a man-made tragedy. What is the amount of rainfall yesterday in Pune, day before yesterday in Pune, जब इतना बड़ा tragedy हुआ है? 16 centimeters. What is the definition of IMD of yesterday's rainfall of Pune? It is not even heavy or intense rainfall. फिर भी इतनी ज़्यादा tragedy क्यों? It is man-made tragedy, right? इट इज़ नॉट नेचर की ट्रेजेडी. नेचर ने अपना नॉर्मल काम किया. इट इज़ अ मैन मेड ट्रेजेडी. ये आपने रिवर्स को ही बंद कर दिया, वहाँ पे बिल्डिंग्स बना दी. रिवर्स को जाने के लिए जगह ही नहीं है, पानी को जाने के लिए जगह ही नहीं है. इलीगल कंस्ट्रक्शन, ऑक्यूपेंसी. यू हैव मेड द रिवर्स वेरी वेरी शॉर्ट फॉर अपार्टमेंट्स, डिस्ट्रॉयड द वेटलैंड्स. ऑब्वियसली पानी विल क्रॉस. एंड सी, इवन इफ द वाटर लेवल इज़ वेरी लेस, बट राजेंद्र नगर की जितनी छोटी गलियाँ है वहाँ पे, because the water, even if the water is less, water will rise upwards because of the narrowness, and when the water rises upwards it will start flowing, and the water has strength with it. It will take away anything. 16 centimeters का rainfall है. You see what IMD has said, moderate to heavy. It is not at all heavy precipitation. Mumbai receives 100 centimeters of rainfall sometimes in a day. 16 centimeters of rainfall है. And see, same things are going to happen in Bangalore now. Next city is going to be Bangalore. उसके बाद दिल्ली में ऐसा नहीं होगा. दिल्ली will not have water. 2020. Yesterday what IPCC said, by 2100 Mumbai will be below the sea. Mumbai will be below the sea. 2100 में. IPCC has released a report, by 2100 if we continue this way, Mumbai will be below the sea. क्या क्वेश्चन डायरेक्टली आएगा कन्वेक्शनल रेनफॉल पे? नेवर. बट वाई देन वी शुड नो हाउ टू यूज दिस पॉइंट्स इन द आंसर. सो फर्स्ट, द रेनफॉल दैट इज कॉज्ड बाय एक्सट्रीम हीटिंग ऑफ द ग्राउंड. Extreme heating of the ground and vertical rise of the air, is known as convectional rainfall. Two conditions are necessary. First, intense heating of the ground. so that air expands and rises upwards. Second, abundant supply of moisture. Abundant supply of moisture. We are going to write the answer slightly different from GS. Next point, solar radiation. Solar radiation is the main source of heat to produce convectional currents. The ground is intensely heated during the day. Between 12 to 3, the ground is intensely heated during the day from 12 to 3. And around 4 o'clock starts giving the heat to the surrounding atmosphere. Which forces the air to rise upwards adiabatically. Cool, which causes increase in the relative humidity. Cool, which causes increase in the relative humidity. Next point, this results into formation of cumulonimbus clouds. Which give very heavy rainfall known as 4 o'clock rainfall. Gives very heavy rainfall known as 4 o'clock rainfall. कन्वेक्शनल रेनफॉल का दूसरा नाम पता याद रखो 4 o'clock रेनफॉल, क्योंकि हमेशा शाम को होता है. नहीं, कहीं पे भी होता है. इंडिया में समर्स होता है 4 o'clock रेनफॉल, क्योंकि शाम को ही होगा. दिल्ली में होता है हमेशा 4 o'clock रेनफॉल. मार्च के एंड में, अप्रैल में, मई में शाम को आंधी आती है. क्या है? 4 o'clock रेनफॉल ही है. 5 बजे के आसपास. Next point. Convectional rainfall is always associated with heavy rains of shorter duration, along with lightning and thunder, and sometimes hailstorms. Sometimes the cold air descends after rain. Sometimes the cold air descends after rain. This cold air is known as squall. Next, April May में देखना अब whenever there is a very heavy rainfall, आंधी के बाद 2-3 दिन बहुत ठंडी हवा बहेगी. Why? Because this air is forced to go up, it cools, and after cooling it becomes heavier and वो descend करेगी. So this is what is the squall. If the question can come specifically on squall, यही लिखना है, convectional rainfall. Can I continue? World distribution of convectional rainfall. The convectional rainfall because of higher insolation throughout the year, is a everyday phenomena in the equatorial regions. Temperature precipitation graphs of the equatorial region show that temperature precipitation graph of the equatorial regions show that double rainfall peaks, double rainfall peaks coinciding with the equinoxes, is the chief characteristics of equatorial type of climate, is the chief characteristics of equatorial type of climate. Understanding this diagram? Bars are rainfall. This color ka red line is temperature. It is somewhere around 30 degrees Celsius. मार्च अप्रैल के एंड में टेम्परेचर थोड़ा बढ़ जाता है, सितंबर अक्टूबर के एंड में टेम्परेचर थोड़ा बढ़ जाता है. हेवी रेनफॉल इज इन द अर्ली अप्रैल, लेट मार्च, एंड हेवी रेनफॉल इज इन द सितंबर. सो डबल रेनफॉल पीक्स. बाकी सब जगह देयर इज अ रेनफॉल पीक, बट डबल रेनफॉल पीक्स coinciding with the equinoxes. Why? 21st of March is equinox, 22nd of or 23rd of September is equinox, and इसीलिए sun is exactly over the equator, therefore maximum rainfall. Sun either in the month of June or in the month of December is very far away from the equator, इसलिए जून में least rainfall and December में least rainfall. Getting it? सॉल्स्टाइस के समय इक्वेटर में सबसे कम बारिश होगी बिकॉज सन इज वेरी फार अवे. सो जून में दैट ग्राफ हैज गॉन बिलो. अगर ये मॉनसून होता तो एग्जैक्टली अपोजिट होता. 4 ही जगह स्काई स्क्रैपर्स होते, दैट इज दिस, दिस, दिस एंड दिस. गेटिंग इट? बाकी खाली होता मॉनसून. एंड ये मैप्स जीएस के लिए भी करना. ऐसे क्वेश्चंस आते हैं जीएस में भी इन प्रीलिम्स. question was directly on global warming, the impact of global warming. Have you listened to the speech of the small girl? Exaggeration भी है उसमें, but it requires guts to speak. जब सामने के audience में मोदी, ट्रम्प, पुतिन जैसे leaders बैठे, कौन से कंट्री की है वो? नॉर्वे. So इसलिए वो she can stare on Trump. If you stare on Modi, you will not be selected. हमारे यहाँ जॉब्स की इतनी प्रॉब्लम है, वहाँ पे जॉब भी नहीं है तो फिर भी गवर्नमेंट विल गिव अ वेरी गुड सोशल सिक्योरिटी. जॉब भी नहीं है तो गवर्नमेंट इज गोइंग टू गिव देम वेरी गुड पेंशन, विच इज बेटर देन द सॉफ्टवेयर इंजीनियर जो कमाता है इन इंडिया. So that is why she could dare to speak. नहीं, नॉर्वे इज 80% माउंटेनियस. 80% माउंटेनियस है नॉर्वे. नॉर्वे डज नॉट हैव 6 months of day. नॉर्वे इज glaciated. It is, you will understand that what determinism has to say. Continue, can I continue? While in the other regions, the convectional rainfall is associated during winters. Convectional rainfall is associated during winters. Convectional rainfall is associated during winters. During the summer season. Next point. कोई भी रीजन हो, साइबेरिया हो, किस भी याद रखना. Next point. Convectional rainfall is less favorable for crop growth. Is less favorable for crop growth because such heavy rainfall is associated with soil erosion. And degradation. Soil erosion and degradation. In fact, आप पढ़ते हो, ये GS के लिए याद रखना, convective rain is associated with leaching. That is, it makes the soil lateritic soil. This soil is rich only in aluminium and iron. You know the process of leaching? सारे compounds are washed away except iron and aluminium, and this is what is the leaching. इसलिए tropical evergreen forestry soils are never good for agriculture. Next point. With anthropogenic global warming, the intensity of the convectional rainfall The intensity of the convections, intensity of convective processes, not rainfall. The intensity of the convective processes, and hence heavy but irregular precipitation of the convective processes, and hence heavy but irregular precipitation is becoming new normal, is becoming new normal, new normal in the urban regions. In the urban regions, the urban heat island effect, the urban heat island effect narrow bylanes, narrow bylanes and concretization gives rise to the effect of urban canyons. Where the hot air is forced to rise upwards, vertically, which sometimes increases the rainfall, but is mostly associated with mechanical inversion, causing a layer of smog and haze in the city, मैकेनिकल इन्वर्जन अगर याद नहीं आ रहा है तो अपर एयर इन्वर्जन लिखो. Smog and haze in the city. Smog will occur only in winters. HAZD, haze. Smog and haze, HAZD, haze in the city. What is the difference between smog and haze? Smog occurs only when there is a fog. When the dust particles will mix with the fog, it will result into smog. Smog के लिए fog है, and therefore fog will occur only in the winters, ground inversion. Therefore smog is associated only in the winters. But Delhi में pollution is high throughout the year. It is because even if there is no fog, there are dust particles in the atmosphere, in the upper atmosphere. This dust particles is what is known as haze. Go to any top building in Delhi and you will see a brown color का layer at the top of the city. That is what is known as haze. क्यों है? Because temperature inversion. क्यों है temperature inversion? Buildings किसकी तरह काम करती है? तोफों की तरह, which is making the warm air to rise upwards vertically, causing upper air inversion. इसलिए urban canyon effect. Urban heat island तो you already know. You should know also what is urban canyon. ऊपर, and therefore pollution. ऊपर. मतलब क्या? एंथ्रो मतलब humans. Anthropogenic means due to humans. All the activities. The class also is resulting into global warming. Projector is running, lights are running, AC is running, coal is burning somewhere, electricity is burning somewhere, emissions are being given out. So greenhouse gases. In सबके लिए electricity चाहिए. Electricity is coming from coal. यही अगर क्लास पार्क में होता है, इन सब की ज़रूरत नहीं है. No emissions. Each and every human activity is associated with warming. Imagine करो ये अगर क्लास छोटे गांव में होता तो you would be sitting out in the open, हवा चलती खुली, एसी की ज़रूरत नहीं पड़ती, खिड़कियाँ बड़ी होती, लाइट की ज़रूरत नहीं पड़ती, हवा फ्रेश होती, एयर प्यूरीफायर की ज़रूरत नहीं पड़ती. Obviously प्रोजेक्टर सब नहीं चलते, but then you would be preparing for civil services. Yes, that is why every development is, I was telling him this example so that you should know कि जितना you are going more towards growth, your carbon footprint is increasing. How much carbon dioxide you are releasing, that is increasing, carbon footprint. mg hector, new car, internet inside, you can switch on the AC from the office, you can switch on the car from the office, right? Means before entering the car, whatever is the office ka temperature is your car ka temperature, but extra fuel is running, which is bad for global warming. कितना time लगता है to open a car, थोड़ी देर खिड़की आधे सेकंड डाउन रखने में और फिर AC चालू करने में, पर नहीं. We want luxury everywhere. It is coming at the cost. See, we are coming to such a bad situation nowadays. जितना आप ऊपर जाओगे हाई राइजेस, उतना पोल्यूशन ज़्यादा. जितना आप नीचे आओगे उतने मच्छर ज़्यादा, उतना फ्लडिंग ज़्यादा, उतना कचरा ज़्यादा. रहे कहाँ आदमी? दिस इज व्हाट इज हैपनिंग. बीच में फर्स्ट फ्लोर, सेकंड फ्लोर, थर्ड फ्लोर, दैट इज व्हाई यू हैव टू पे एक्स्ट्रा प्रीमियम फॉर फर्स्ट फ्लोर, सेकंड फ्लोर. कभी कभी 25 लाख ज़्यादा फॉर फर्स्ट फ्लोर एज कम्पेयर टू द सराउंडिंग रीजन्स. Fine, this is what, why they charge you. Yes, first floor से चलो. आजकल के अपार्टमेंट्स में they higher you go, more they charge you. See, in Delhi, higher you go, more they charge you. In Mumbai, higher you go, less they charge you. मुंबई में मैक्सिमम इज ऑन द फर्स्ट फ्लोर, सेकंड फ्लोर, थर्ड फ्लोर, फोर्थ फ्लोर. ग्राउंड फ्लोर पे मुंबई में आगे जाके तो कोई नहीं रहेगा विद द सिटी नाउ कि फर्स्ट फ्लोर तक डूब ही जाता है घर हर मानसून में. फर्स्ट फ्लोर तक तो पानी आ ही रहा है मानसून में. सो व्हाई? बिकॉज इन मुंबई इफ यू गो हायर एंड हायर, कुछ फायदा नहीं होगा. दिल्ली में देयर आर नो हाई राइजेस, सो यू विल सी ग्रीन एरिया. मुंबई में हायर यू गो, आपको अनऑब्स्ट्रक्टेड व्यू मिलेगा सामने के घर का. फाइन. So nobody wants to go much higher. Fine, this is with the convectional rainfall. So understanding the convectional rainfall and associated process of globalization, global warming. Global warming is going to increase the convectional rainfall, and therefore Kerala floods, Mumbai floods, all this will be common in the future because we are now causing urban heat island and urban canyon effect. Next, not that all important, so for formality I am doing this, orographic rainfall. It is caused by a mountain barrier in which the wind is forced to rise upwards by the mountain barrier, cool adiabatically, and therefore give very, very heavy rainfall as it is going upwards. This side of the mountain is known as windward side. Afterwards, the wind is forced to come down. As the wind is forced to come down, it heats up adiabatically, and therefore यहाँ पे rainfall कम होता है, which is on the leeward side, is always rain shadow region. Clear? So 2-3 points यहाँ पे, caused by a mountain barrier, where the air after hitting the mountain, perpendicular mountain barrier, where the wind after striking the perpendicular mountain barrier is forced to rise cool adiabatically, and give precipitation, cool adiabatically and give precipitation. Very heavy rainfall occurs. Very heavy rainfall occurs due to the ascent of the wind on the windward side. The amount of rainfall starts increasing from the foothills. True or false? Amount of the rainfall starts increasing from the foothills. आगे का point very important. In the high mountains, as the air rises upwards, after a certain height, the rainfall decreases. क्यों rainfall decreases? Because there is no new source of moisture. The rainfall decreases. And this feature is known as inversion of rain. This feature is known as inversion of rain. यहाँ पे this layer is the layer of inversion of rain. ये Himalayas में होता है very frequently because the mountains are very, very high. So after the red line, ऊपर के height में there will be very less or no rainfall, and this is what is known as inversion layer of the rain. And ये सब optional में लिखो, GS में कोई ज़रूरत नहीं इन सब चीज़ों की. Next. Many times orographic rainfall is not just due to the mountains. many times orographic rainfall is not just due to the mountains alone, but also due to associated convective mechanism. That was his doubt, associated convective mechanism during the daytime. Convective mechanism during the daytime. अब देखो, what is this convective mechanism? Suppose this is a mountain. Convective mechanism during the daytime. Suppose this is a mountain. नीचे very high mountain. So as you go up, rainfall कम हो रहा है. As you go up, the vegetation कम हो रहा है, climate कम हो रहा है. And as a result of this, there is a bare rock. Soils भी नहीं होगा. So during the daytime, this rock will absorb large amount of heat and become very, very hot. And as a result of this, low pressure will develop here, only during the daytime. Due to the low pressure being developed here, wind will start rising upwards convectively due to the low pressure. यहाँ से wind निकल जाएगी due to low pressure. As a result of this, side वाली wind will try to go to the region जहाँ पे there is a low pressure develop. यहाँ पे low pressure develop हुआ, the air from here is removed away. Therefore, the air from the surrounding regions will try to take its path. अब this air will be forced to rise upwards and give the rainfall. इसीलिए we have said कि not just due to orography, also due to convective mechanism. When the wind is blowing, there is no doubt कि convective mechanism will occur. But suppose sometimes wind blow ही नहीं कर रही है, then also there is a rainfall. How? This is due to the convective mechanism. Low pressure develops and then the wind starts blowing. Getting it? The daytime heating causes anabatic means up the slope. Causes anabatic, upslope valley, upslope mountain breeze, causes anabatic upslope mountain breeze, which gives rainfall. Next point. Unlike the convectional or the cyclonic rainfall, orographic rainfall is not dependent upon seasons. Orographic rainfall is not dependent upon seasons. See, rest of the things GS ka you already know. Mountain is to be perpendicular to the wind direction, not parallel. If it is parallel, it will not be forced to rise up. Second, maximum difference of rainfall is between the two places of windward and leeward side. So एक favorite question भी है UPSC का, कौन से दो places के बीच maximum difference of rainfall है? One option is Mumbai, then second option is Pune जो NCERT ने दिया है, या Bangalore. Which two places will record maximum difference in the rainfall? Bangalore or Mumbai, Pune, right? So, matlab they will give you four options: Allahabad, Varanasi, Delhi, Jaipur, Mumbai, Pune, and one more pair of cities. Hamesha answer will be either Mumbai or Pune or Bangalore, because one is the windward side, the other is the leeward side. Clear? Plateau भी हो सकता है. Western Ghats actually mountain नहीं है. यहाँ पे बैरियर के कारण राइज हो रही है. एयर राइज होनी चाहिए, वो राइज हो रही है इधर ड्यू टू हीटिंग कन्वेक्शन रेनफॉल, इधर ड्यू टू माउंटेन बैरियर ओरोग्राफिक रेनफॉल, इधर ड्यू टू फ्रंट्स फ्रंटल रेनफॉल। 3 टाइप के रेनफॉल अलग है। तो फ्रंटल रेनफॉल में आएगा ना, साइक्लोन यहाँ पे आएगा ही नहीं। साइक्लोन फ्रंट थर्ड है ना, 3 टाइप्स ऑफ रेनफॉल है, ओरोग्राफिक, कन्वेक्शनल और तीसरा फ्रंटल। फ्रंटल साइक्लोनिक इज फ्रंटल। तो फ्रंटल जब हम रेनफॉल की बात करते हैं तो हम सिर्फ टेम्परेट साइक्लोन्स, वी टॉक ओनली अबाउट द टेम्परेट साइक्लोन्स। If you are saying tropical cyclone, it is a phenomena in itself that is caused due to thermal heating. We don't take it as a kind of a rainfall. We talk only of the frontal rainfall which is formed along the fronts. Fronts are formed only in the temperate cyclones, never in the tropical cyclone. So there is no 4th type, there is only 3 types. Tropical cyclone is a totally different phenomena. It is associated with convective heating only, but of the ocean surface, not of the land surface. Getting it? Clear? See, there are 3 kinds of rainfall. Convectional, orographic, cyclonic. When we say this is cyclonic, this means frontal. And this means, that is what we are going to do third, is the I will come to this later on, associated with fronts and temperate cyclone. But understood the condition for the rainfall, कब rainfall होगा, कब नहीं होगा. What is the first condition for the rainfall? The air has to rise upwards. And with this background, we come to the important topic of stability and instability of the atmosphere. And here we should know the types of instability. What will be the stability? If the air does not move upward or downward, that is what is known as a stability. मतलब नीचे there is a cold air, कब नहीं जाएगी air ऊपर या नीचे? जब नीचे there is a cold air and ऊपर there is a warm air. But in this case, when there is warm air below and there is a cold air above, the cold air being denser will try to come down, the warm air being rarer will try to go up, and this will result into the atmospheric instability. As the warm air is rising upwards, it will cool and form clouds, and then it will give the rainfall. What causes the stability? The stability is always dependent upon the relationship between the normal lapse rate, atmospheric lapse rate, dry adiabatic lapse rate and moist adiabatic lapse rate. इसमें से कौन से कांस्टेंट है? ये दो ही कांस्टेंट है. This we take average as 6.5 degrees Celsius for every kilometer, but you should know this varies. Fine? This varies. अब प्रीलिम्स में जीएस में क्वेश्चन आता है व्हाट इज नॉर्मल लैप्स रेट, डोंट राइट इट वेरीज, इट इज 6.5, बट ऑप्शनल में इट कीप्स ऑन वेरिंग, इट कैन बी 15 डिग्री सेल्सियस ऑल्सो, इट कैन बी 11 डिग्री सेल्सियस ऑल्सो, इट कैन बी 2 degree Celsius also, it can be 6 degree Celsius also, it can be 6.5 also. Average value of the world is 6.5. See, atmosphere किस rate से, if the air is stagnant, at what rate the atmosphere में temperature is decreasing is what is known as the normal or atmospheric lapse rate. अब what rate पे this atmosphere का temperature as you are going up decreasing depends upon what is the condition on the ground. If the ground condition is dry, it will be faster. If the ground condition is moist, it will try to retain the heat, it will be slower. अगर बाजू में mountains है, mountains का vegetation क्या है, it depends upon numerous factors and therefore normal lapse rate is never constant, it keeps on varying. Fine? So this is what is the stability, instability, very very important topic in our syllabus and थोड़ा tough है ये. So first, stability and instability. The humidity, pattern of the air masses, and the weather conditions of the world, are dependent upon the concept of stability and instability in the atmosphere. Concept of stability and instability in the atmosphere. Stability and instability determines the states of equilibrium. And the changes to that state. Full stop. When the air tries to resist, the vertical displacement, the air is said to be in the stable equilibrium. याद कर लो इसको. And don't confuse with the Savindra Singh का example. When the air tries to resist the vertical displacement, वो vertically move नहीं करेगी upwards. वो क्या air है? Stable. क्यों move नहीं करेगी upwards? Maybe उसका density is different. Maybe उसका temperature is colder. कि वो और ऊपर नहीं जा सकती. Fine? It depends upon temperature and density. Clear? Next. Under the conditions of stable equilibrium, there is a complete absence of convection or convective activities, and therefore weather is cloudless and clear. According to Trevartha, according to Trevartha. You can start with anything. मैं आपको 2-3 starts दे रहा हूँ. Air is said to be stable. Air is said to be stable, and consequently antagonistic. Antagonistic means what is antagonistic? Opposite. कहाँ पे यूज होता है वर्ड एंटागोनिस्ट? जनरली मूवीज में विलन्स के लिए, बिकॉज ही इज ऑलवेज अपोजिट एंड ही डज नॉट फेवर. फाइन. एंटागोनिस्टिक टू प्रेसिपिटेशन. Air is said to be stable and consequently antagonist to precipitation if it is non-buoyant, B-U-O-Y-A-N-T, buoyancy नहीं है, that is up downward movement नहीं है, non-buoyant, and resists vertical displacement. Stop. On the other hand, if the displacement results into buoyancy, and tendency for further movement, away from the original position, the air is said to be unstable. Understood? Stability and instability. Air is said to be unstable. Types. सबसे पहले the stability and the instability, depends upon the equation or relationship between dry adiabatic lapse rate moist adiabatic lapse rate and normal lapse rate थोड़ा समझ लो. If you are going for other classes, ये lecture जरूर watch this very properly. थोड़ा mathematical equation है. I am taking dry adiabatic lapse rate as 10 degrees Celsius for every kilometer. I am taking the normal lapse rate as 6.5 degrees Celsius for every kilometer. Fine. So we will first write what will be the values of the normal lapse rate. यहाँ पे 30 degree Celsius. So यहाँ पे the normal lapse rate will be 23.5 degree Celsius. Fine. यहाँ पे it will be 23 minus 3, 20, 17, 16.5 degree Celsius. यहाँ पे it will be 10 degree Celsius. Right? This is the parcel of air. Parcel of air is different from the atmosphere because this is the only air which is going to go up and down. Pura environment or pura this region is not going to go up and down, only this air mass is going to go up and down, and therefore we will call this as a parcel of air. Imaginary concept. ये ऊपर जा रहा है and it is now cooling at dry adiabatic lapse rate. So parcel of air near the ground will have the temperature which is of the ground, 30 degrees Celsius. When it will come to this height, यहाँ पे the temperature of the parcel of air will be, what is the dry adiabatic lapse rate? 10 degrees Celsius. What will be the temperature? 20 degrees Celsius. उसके ऊपर वो जाएगा नहीं. But चलो we'll take the condition even if it rises up here, वो आके यहाँ पे रुक जाता है. What will be the temperature? 10 degrees Celsius. So this parcel of air which is going upwards, is it cooler than the surrounding air or warmer than the surrounding air? Cooler. And the cooler air has the tendency to rise upwards or descend? Descend. And therefore we will say stable equilibrium is when dry adiabatic lapse rate is greater than normal lapse rate. Understanding? This is what is the stable equilibrium. When dry adiabatic lapse rate is greater than normal lapse rate. Is it not always greater? No. Because you can see what is instability. Normal lapse rate I told varies, and suppose the normal lapse rate is 11 degrees Celsius per kilometer. Wet adiabatic lapse rate varies from 5 to 6. Normal lapse rate varies from 5 degrees Celsius per kilometer to 20 degrees Celsius per kilometer. Itna variation hai normal lapse rate. Fine. Now it is 11 degrees Celsius per kilometer. So what is the temperature of normal lapse rate? 30 के बाद 19, इसके बाद 8, उसके बाद minus -3 degrees Celsius. Yes. This air is going upwards at dry adiabatic lapse rate. यहाँ पे आके it is cooler than the, which air is cooler? Surrounding air is cooler. So this is warmer. Because it is warmer, it will try to rise up. और ऊपर आएगा, इसका temperature is warmer than the surrounding air. It will try to rise upwards, and we will call this as instability. Instability occurs when dry adiabatic lapse rate is lesser than normal lapse rate. Understanding? ये तो just start है अभी, यहाँ तक समझा कि नहीं? इसके बाद अभी ये तो first है, stability, instability. अभी आना बाकी है, convectional, conditional, mechanical. Fine? Have you understood? ग्रेटर होगा तो स्टेबिलिटी, लेसर होगा तो इंस्टेबिलिटी. सी दिस इज कोर ऑप्शनल का टॉपिक. ऑब्वियसली इसलिए ये डिफिकल्ट लगता है बिकॉज यू हैव नॉट स्टडीड इट इन जीएस. बाकी कुछ डिफिकल्ट नहीं है, एंड इसमें याद रखना पड़ता है. दिस आर द टॉपिक्स जिसके माइक्रो नोट्स होने चाहिए एग्जाम से पहले, बिकॉज लिखना तो आपको सिर्फ ये इक्वेशन एक्सपांड करना है, एक डायग्राम बनाना है और एक इमेजिनरी वैल्यूज लेनी है. बट एग्जाम में ये नहीं भूलना चाहिए व्हेन इज स्टेबिलिटी, व्हेन इज इंस्टेबिलिटी. अगर इतना याद है माइक्रो नोट्स से, इफ यू हैव माइक्रो नोट्स रेडी जस्ट बिफोर द एग्जामिनेशन, इफ यू रिवाइज दिस, देन fine? You can easily write an answer. See, on my Facebook page, I have shared one message of my student, जिसने एक दिन पहले मुझे WhatsApp किया था for the students who are going to write mains. उसने एक मैसेज भेजा था, मैंने वो Facebook पेज पे भी डाला और जो मेंस लिख रहे थे उनको भी दिया था. Dear friends, soon to be colleagues, so finally the dreadful time has arrived. We may think that it is days away, but then it comes and then realization occurs. This realization brings in a lot of stress and anxiety along with the sleepless nights. My sincere request is to stay calm and not to panic, and those who stay relaxed perform the best. At the end of the day, it is just another exam. Don't forget the political masters ruling the country have never ever appeared for this exam. Fine. I like to give you some pointers. I am not reading all the pointers. One of the pointer he has said is keep revising till the last moment even before entering the exam hall. ये प्रीलिम्स नहीं है कि आपका दिमाग शांत होना चाहिए और एग्जाम हॉल में जाने से पहले किताबें बंद करके शांति से बैठो. यहाँ पे मेंस है. एक एक पॉइंट एग्जाम हॉल में जाने से पहले रिवाइज करना चाहिए ताकि एक सेंटेंस याद आ जाए, एक लाइन याद आ जाए. यू नेवर नो व्हेन इट क्लिक्स वेयर दैट. Fine. The war in this exam has two parts, preparation 50% and the exam 50%. No matter what is your level of preparation, it does not matter. Give your best shot in this 3 hours, give your blood and sweat and everything that you have got. Write and underline till the last moment. Your description to clear the your desperation to clear the exam should be visible to the examiner in the terms of efforts you put in the answer sheet. That is why I said presentation. मेहनत दिखनी चाहिए आंसर में. Fine? So मैं बाद में दूंगा ये मैसेज आपको, but these are the 2 points. So ये pointers है. Generally मैं इसमें हमेशा भूल जाता था. And ये question हर alternate year में आता है, stability instability वाला. Fine? So when is the dry adiabatic lapse rate? When is the wet adiabatic lapse rate? So first, types में first stability and instability. Second types is conditional. Third is mechanical. So first stability and instability. स्टेबिलिटी एंड इंस्टेबिलिटी दोनों मैं एक ही इसमें करूँगा. स्टेबिलिटी, दिस इज इंस्टेबिलिटी. So you can start with Trivartha, you can start with anything and directly come to stability and instability. So point number 1. The dry adiabatic lapse rate of the air is 10 degrees Celsius per kilometer. Which is always fixed, while the environmental lapse rate is variable. Environmental lapse rate is variable. When the dry adiabatic lapse rate of a parcel of air which is ascending, बहुत ही सिंपल ऐसे वर्ड स्टफ है, which is ascending is higher than the normal lapse rate. एग्जाम में बार बार मत लिखो, एक बार लिख के ब्रैकेट में ये लिख लो ड्राई एडियाबैटिक लैप्स रेट, एक बार लिख के नॉर्मल NLR लिख लो, and then you can use this shortcuts. These are universal shortcuts. Fine, is greater than normal lapse rate. And if it does not attain a dew point, if it does not attain saturation, एक बार saturation होने के बाद तो बारिश होगी. If it does not attain a saturation, it becomes colder than the surrounding air. It becomes colder than the surrounding air. It becomes colder than the surrounding air. Such air will resist upward movement. Such air will resist upward movement. And is said to be at the stable equilibrium. Said to be at stable equilibrium. Example, if the surface of temperature of a parcel of air, if the temperature at surface of the parcel of air is 40 degrees Celsius, and it starts cooling at dry adiabatic lapse rate, when the normal lapse rate is 6.5 degrees Celsius, when the normal lapse rate is 6.5 degrees Celsius, after 1 kilometer, the temperature of air parcel will be 20 degrees Celsius, it will be 30 degrees Celsius, while the temperature of the surrounding air will be 33.5 degrees Celsius. Temperature of the surrounding air will be 33.5 degrees Celsius. And being cooler, it will resist upward movement. Next point, don't draw the diagram abhi. Sometimes the environmental lapse rate is very less of around 4 degrees Celsius. Sometimes the environmental lapse rate is very less, around 4 degrees Celsius. In such condition, if the air is ascending even with dry adiabatic lapse rate, in such condition, if the air is ascending even with the wet adiabatic lapse rate of 5 degree Celsius, the temperature of the air parcel becomes 35 degrees Celsius. I'm sorry. Should you draw this diagram? Let me think what it is. Yes, yes, we can continue writing. I'm sorry, कुछ नहीं कर, मैं ही कंफ्यूज हो गया था. टेम्परेचर देखो, ये इसलिए मेरे को डर लगता है इस टॉपिक का. आफ्टर सो मेनी ईयर्स ऑफ टीचिंग मैं खुद कंफ्यूज हो जाता हूँ. We can continue writing, then you draw the diagram. 4 degrees Celsius, the temperature of air parcel will become 35 degrees Celsius, while the temperature of the surrounding air as per the lapse rate is 36 degrees Celsius. Such a condition when the moist or the wet adiabatic lapse rate, कुछ भी लिखो एक, the moist or wet adiabatic lapse rate is greater than environmental lapse rate, it is known as absolute instability. No, you can't draw this diagram. Stability, absolute stability. Stability में dry adiabatic lapse rate should be greater than normal lapse rate. Absolute में even the moist adiabatic lapse rate should be greater than the normal lapse rate. Getting it? I'm drawing here for you to ये दोनों अलग है. Getting it? कुछ नहीं, simple है, just confusion क्यों होता है? Why I still get confused? Because of the wrong things we have been told. कि normal lapse rate is 6.5 degrees Celsius per kilometer. That is never the case. It varies. Why we have been told these things? Because for a common man, उसको अगर इतना confusing दे दिया, फिर वो कभी geography की तरफ आएगा नहीं. Fine? So therefore, उसको कहा जाता है normal आदमी के लिए wet adiabatic lapse rate, moist air. Dry adiabatic lapse rate, dry air. Moist air will always cool at a slower pace because it has the capacity or tendency to retain the heat. So every time climatologist will determine जो air ऊपर जाएगी, we already know this parameters are fixed. Fine? इसमें थोड़ा variation है 1 degree Celsius का. Therefore, climatologist will always determine what is the normal lapse rate. And if the normal lapse rate is fixing this condition, वो कहेंगे rainfall के chances कम है. If the normal lapse rate is not in this condition, वो कहेगा rainfall के chances बहुत ज़्यादा है. When कहाँ rainfall के chances बहुत ज़्यादा है? Dry adiabatic lapse rate is 10 degrees Celsius. Normal lapse rate is 12 degrees Celsius. So when the air is going upwards, it is cooling initially at the dry adiabatic lapse rate. After 1 kilometer, उसका temperature becomes 20 degrees Celsius. Surrounding air का temperature is 18 degrees Celsius. So this air parcel is warmer than the surrounding air, and इसलिए it will continue moving upwards. इसको हम कहेंगे instability. And absolute instability, the same phenomena. Once you understand this, instability is very easy. So clear यहाँ तक? Clear? Instability. When the normal lapse rate is greater than the dry adiabatic lapse rate, is greater than the triadiabatic lapse rate. Then the parcel of air continues to rise upwards, expands and becomes unstable. Example, if the triadiabatic lapse rates, I'll take the same example, if the triadiabatic lapse rate and the normal lapse rates are 10 and 11 degrees Celsius respectively, the air after reaching 1 kilometer will have a temperature of 30 degrees Celsius. While the surrounding environment will have a temperature of 29 degrees Celsius. The surrounding environment will have a temperature of 29 degrees Celsius. And hence, the air parcel is warmer than the surrounding air. And will continue to rise upwards. Resulting into instability. Fine, you can draw this diagram. will take the same values जो मैंने अभी ली है. Yeah, you can take the value even of the normal lapse rate 6.5 also, but मैं वही लेता हूँ so that it becomes easy for you to understand. 11 degrees Celsius. Moist adiabatic, wet adiabatic lapse rate is 5 degrees Celsius. So at the ground 40 degrees Celsius is the temperature near 0 kilometers. After 1 kilometer, this air parcel ka temperature will be, it is cooling at the wet adiabatic lapse rate. How much? 35 degrees Celsius, while the surrounding air ka temperature will be 29 degrees Celsius, and therefore this air parcel is very, very warm as compared to the surrounding air parcel, which is cold, and we'll call this situation as absolute instability. Oh, sorry. Can I continue? As the air parcel will continue to move upwards, after becoming saturated, ऊपर जाते जाते कभी ना कभी तो सैचुरेटेड हो जाएगी. Saturated means relative humidity will become 100%. Then the ascending air parcel moves at wet adiabatic lapse rate, moves upwards at wet adiabatic lapse rate. In such cases when the normal lapse rate is greater than the wet adiabatic lapse rate, normal lapse rate is greater than the wet adiabatic lapse rate, wet adiabatic lapse rate, It is known as absolute instability. It is known as absolute instability. Full stop. Next paragraph. When the ascending air parcel reaches at such a height, when the ascending air parcel reaches at such a height, that its temperature becomes equivalent to the temperature of the surrounding air. Then such situation is known as neutral equilibrium. क्या होगा in the neutral equilibrium? It will continue to move upwards or it will stop? It will stop. Neutral equilibrium. दोनों का temperature is going to become same. Next point. Sometimes in the regions of cold fronts, or abnormal conditions, the normal lapse rate is very high. Around 20 degrees Celsius to 35 degrees Celsius per kilometer. Remember, it is never fixed at 6.5. 20 degrees Celsius to 35 degrees Celsius per kilometer. क्या होगा इसमें? The air will continue to move upwards, whether it is cooling at dry adiabatic or moist adiabatic. Well, it will move upwards at a slow speed or at a very high speed, because surrounding air is extremely cold and denser. So it will move upwards at very high speed. So when it moves upward at a very high speed, you will call such situations as tornadoes. Environmental lapse rate is very, very high. Air is extremely dense and cold. So the upper air, ये जो air parcel जो move कर रहा है, it is much warmer as compared to the surrounding air. And warmer है इसलिए low pressure becomes intensified. And इसीलिए इसी जगह से air is being moved upwards. And this is what is known as tornado. Getting it? So where did I say? Stop. In such conditions, the upper layer of the atmosphere become extremely cold and denser. Upper layers of the atmosphere become extremely cold and denser. Stop. This air descends and pushes the warm air upwards. This cold air descends and violently pushes the ground air upwards, and violently pushes the ground air upwards. देखो, यहाँ से cold air is descending and जब भी air is descending, high pressure, therefore no cloud formation, we cannot see that. It is coming in this region like a squall and it is pushing the ground air upwards, understanding, and the ground air is going upwards at a very high speed. जब तक कोई push नहीं करेगा, ground air will not move upwards at a very high speed. कहाँ से आ रही है cold air? Cold air is coming mostly from this side, and इसलिए warm air is going upwards like this. In this situation, cold air is coming from both the sides, and therefore warm air is going upwards vertically. Getting it? Upwards. Such situation is known as mechanical instability. Such situation is known as mechanical instability, which results into the formation of tornadoes, and water spouts. You already know what is water spout? Nothing but tornado on the water surface is water spout. So this is again ocean में से पानी जैसे ऊपर जा रहा है. This is a water spout. This is a water spout. Or this is a water spout. ये पूरा ocean का पानी, it is going upwards. And tornado is always on the land. Water spout is always on the oceans. We'll see this photo. Right? So I'll stop here today. Tomorrow you are having test 2 to 5. And we are meeting on Sunday, same 2:30 to 6. क्या? सारा means? नहीं, climatology नहीं है. Ocean, my focus will be on geomorphology and easy questions of oceanography, जो पता होने चाहिए. Revise the theories of coral reefs, उसका एक question है, चलो. Fine. Revise the mid-Indian Ocean ridge, at least Atlantic Pacific नहीं पर Indian Ocean ridge कर लो, mid-Indian Ocean ridge, उसके ऊपर एक question है. Fine. Revise tides, उसके ऊपर एक question है. Question paper will also be available online.